Alright, lesson 6.5 is about trapezoids and kites, and our objective is to verify and use properties of trapezoids and kites. So first let's check out some new theorems. The first one is theorem 615. It says that the base angles of an isosceles trapezoid are congruent. Theorem 616 says the diagonals of an isosceles trapezoid are congruent. The base angles of the trapezoid are the two angles that share the base of the trapezoid. So the top two would be base angles, the bottom two would be base angles because they both share one of those parallel sides. And then the two left and right sides are called legs. Then there's one theorem about kites. It says the diagonals of kites are perpendicular. Okay, and then page 111. First example says finding the angle measures in trapezoids. WXYZ is an isosceles trapezoid, and the measure of angle X is 156 degrees. We're going to try to find the measure of angle Y, Z, and W. Two angles that share a leg of a trapezoid are supplementary. So angle X and angle W are supplementary, which means they add up to 180. We know that X is 156, and it's still equal to 180. If we subtract 156 from both sides, we know that W is 24 degrees. Because the base angles of an isosceles trapezoid are congruent, we know that Y is 156 and Z is congruent to the measure of angle W, and we know that W is 24. So Z is also 24. Okay, so that's isosceles trapezoids. This next one is also about isosceles trapezoids. It says half a spider's web is shown to the right, formed by layers of congruent isosceles trapezoids. Find the measures of the angles A, B, C, and D. So trapezoid ABCD is part of the isosceles trapezoid whose vertex is at the center of the web. So this is the vertex. Because there are 6 adjacent congruent vertex angles, the center of the web together, forming a vertex angle, each vertex angle measures 180 divided by 6, or 30 degrees. So all that was saying is we have half of a circle here, so that's 180 degrees. There are 6 angles coming out of that half a circle. So if you take 180 divided by 6, each of these angles is 30 degrees. By the triangle angle sum theorem, A plus B plus 30 equals 180, because the triangle adds up to 180. So what that is saying is if we look at this triangle, where it meets the vertex angle, we know this is 30. If we add all those up, it has to equal 180. So the measure of angle A plus B, so if we subtract 30 over the other side, equals 50. Because ABCD is part of an isosceles triangle, A and B are equal, so 2 times the measure of angle A equals 150 degrees. So that means if we cut it in half, both A and B are 75 degrees. Since it's an isosceles triangle, these are both the same measure. So we could divide 150 by 2. Another way to find the measure of each acute angle is to divide the difference between the measure of the vertex angle by 2, which is what we said. We did 180 minus 30, which was 150, divided by 2 was 75. Because the bases of the trapezoids are parallel, the two angles that share a leg are supplementary. So now we're just looking at the trapezoid that's formed. So that would be just A, B, C, D here. What they're saying is these two are supplementary and these two are supplementary. So if I'm trying to find D, I can do 180 minus 75 because I know that A and B are 75 degrees. 180 minus 75 would get us 105. So both C and D are 105 degrees. Okay, there's a check for understanding problem here to check out. It says in the isosceles trapezoid, the measure of angle S is 70 degrees, and you need to find angle P, Q, and R based on the rules that you know. Okay, let's take a look at example 3 here. Finding angle measures in kites. So we're going to find the measures of the numbered angles. We know that the measure of angle 2 is 90 degrees because the diagonals of a kite are perpendicular. That was a theorem that we learned earlier. Perpendicular means it forms a 90-degree angle, so measure of angle 2 is 90. We know that RU is equal to RS. It's marked here. It's also the definition of a kite. It's not a kite if the two adjacent sides are not equal. So to find the measure of angle 1, we can use the isosceles triangle theorem. Since those are equal, this makes an isosceles triangle. And since this side is 72, that means angle 1 is also 72. Then we know that the measure of angle 3 plus angle RDU plus 72 equals 180, because that's a separate triangle. And that's by the triangle angle sum theorem. So we are just looking at this triangle here. So then we know that RDU is 90 degrees because the diagonals are perpendicular. So we can replace RDU with 90. It's still equal to 180. 90 plus 72 is 162. It's still equal to 180, and then if you subtract 162 from both sides, the measure of angle 3 is 18 degrees. So we found the measure of angle 1, 2, and 3. Okay, there are a couple more check for understanding problems here for you to check out. First one says the middle ring of a piece of the ceiling is shown made from congruent isosceles trapezoids. Imagine a circular glass ceiling from the ceiling pieces with 18 angles meeting at the center. So again, this is your vertex angle. What are the measures of the two sets of base angles of a trapezoid? So there's 18 angles. You got to keep in mind from example 2, we did half the circle divided by the number of angles we had. In this one, it's saying there's 18 angles in the whole circle. So you need to divide 360 by 18 to figure out what one angle is. Then you can find out what these two angles are because it's an isosceles triangle. And then you can figure out the other two because they're supplementary with the bottom angle. Angle, or number 3, says to find the measures of angle 1, 2, and 3 in the kite. So that is going to be very similar to example 3 up here. Use what you know about kites to find out each of the angles. Okay, so now is your time to start working on these problems. I will make a video that explains how to do them so that when you are done, you can check